Okay, so my name's Luke. My advisor is Dr. Hernandez, and I'm building a device that I called the Creative Keypad. So this is the agenda. I'll go over like the initial thoughts and description of the project, like why I wanted to create it, probably some comparison to some other products I found, and then basically the results, which is, well, this is just the task I did this semester, which is probably more important than what I did last semester. So description. So like I wanted these keypads exist. So if you go on Amazon, you search like macro keypad or anything, they do exist, but they're often just it's often just like either a number pad or they just take half a QWERTY keyboard and sell it. And there's really no programmable features on them. And like the programmable ones do exist too, but sometimes they can get really expensive depending on what features they have. And sometimes they'll only work for a specific program. For example, like I know there's a device that only works on Adobe Lightroom, and I think it costs like $300 or something. So what I want to do with this device is create kind of a low cost keypad that has like the features of the programmable ones, but with like the price of the standard ones you find elsewhere, along with like some other features such as, so I think like the main feature of my keypad is that it uses rotary encoders as an input, which is unique to these more specialized ones keypads. So like the initial thoughts about how I came up with this is I used to use a Wacom tablet with the shortcut keys. So on the left, like that's the Intuos 4. It had that the one thing I used the most was that little circle pad in the center. It was a capacitive touch thingy, and you could map it to something like say you're drawing something, you want to increase your brush size, you just rotate that like counterclockwise or clockwise, and it would increase or decrease the brush size. And there was also a button in the middle. You could cycle between, I think it could store like up to 4 or 6 settings. So one setting could be brush size, another setting could be rotate the screen, another one could be opacity or zoom in, zoom out. So that's convenient, but again, you have to cycle through them, and you can only, if you miss like the thing, you have to cycle all the way back through until you get the one, and it gets kind of cumbersome. So, and then I upgraded to a screen tablet made by XP Pens that's on the right. It has has 6 keys here for shortcuts, but it doesn't have that circle pad that I've grown used to. And it's just kind of weird using the keys for stuff like zooming in or zooming out, if any. That's kind of how I got the idea to do this. So I wanted to create an affordable device for creative software with plenty of inputs. So this device has 12 switch-based inputs and 6 other inputs, which are those rotary inputs. And just some product comparison, the Wacom remotes, like it's similar to the one I showed you on the Wacom tablet. It is just the same thing, but with more push buttons. It still only has one of those rotary inputs. And XP Pen sells their kind of own version of it, but it's kind of like the same idea as the Wacom remote. It only has one rotary button and 9 push buttons. And I don't think the one in the center lets you cycle what the rotary button does. I think that's just an additional button, but that one's $30. It's small. They're both wireless and small. I think they're meant to be put on the tablet itself. And this was like the big one, like when I was talking about the specialized ones, the Loop Deck CT is kind of more niche. It has plenty of macros, even a touch display. It has 6 of those rotary inputs and I guess 7, but it's also $550, which is actually more than the display tablet I have. So you can see how it gets quite expensive. So this device, so that's just kind of 3D render I did. You can see I kind of got inspiration from that Loop Deck. So it would have under $150. It would be wireless with a rechargeable battery, have plenty of input. So I have the 12 push buttons and the 6 rotary buttons. So next are some milestones, and this is for this semester. Like last semester, I created a prototype of the device here, kind of as a basis of what to do. So first, I created a custom PCB based on the prototype and the circuits I created. So I just made this in Circuit Maker. It's quite simple. So it just uses a standard keyboard matrix for the switch buttons, and the rotary inputs, I think, just use pull-ups connected. Each one is connected to two IO pins on the MCU. So which for that, I'm using a Teensy 2.0. And for the wireless connectivity, I decided to use a Adafruit Bluefruit LE, it's a Bluetooth LE device that works over serial connection between the MCU and that device. I think it uses some Nordic processor for the actual Bluetooth communication. And the encoders are just standard quadrature encoders. And that's a 3D render that was given by a circuit maker. So yeah, I use Cherry MX switches for the switches. They're kind of bulky, but they're really nice. So for the price of all the components, so for the PCB at JLC PCB, it's $30 for 5 PCBs. So that's $6 or 6 per PCB. All the components, all the resistors, capacitors, switches, and that was $55 total. The Bluefruit and battery system was kind of the more expensive part of it. So I have it as optional because you can use the device wired. You wouldn't need the Bluetooth or the batteries in that case, but those come to around $37 for all of them. And the grand total is roughly around $100, which is well under the 150 goal I set. So that's a picture of the PCB with all the components mounted and the encoders and switches. So next up, I had to create a case for it. So that was designed in Autodesk Inventor, and I could actually export the 3D model from Circuit Maker of the PCB to this and build around it to ensure that it fits. And obviously the case protects the components and it makes the product actually look like a product. So that's the top of the case. There's really nothing special about it. It has holes for the encoders and the keypad. That's the bottom. That's where the PCB is mounted to. And that's it. It's realized it looks kind of bare. But I guess one problem with it was that the top of the case was too thin, so that needs another revision. So next was the firmware. So the firmware is what runs on the Teensy MCU on the device. I decided to use an open source mechanical keyboard firmware as the base, is known as TMK. But it's been heavily modified so that TMK is essentially only responsible for actually sending the input. Because I had to write the matrix logic and the encoder logic myself, and that was the bulk of it. And I also had to modify the TMK firmware to actually support the Bluetooth LE because it doesn't support it out of the box. But this is just responsible for taking the user input and sending it to the PC. So yeah, I did add Bluetooth support. So the thing with the Bluetooth support is that I don't need to use custom kernel drivers. I can just use a software on the PC to receive the data and handle it. And yes, it can work over wired communications. Originally, it just acted as an HID keyboard. So like even the encoders, whatever direction you rotated them, it would just send like a key. And this was hard coded, but I wanted to change that so it's customizable. So the software is responsible for taking the serial data from the device and translating it to keystrokes via the operating system APIs. So there's two parts of the software. There's configuration, which is the front end, and the service, which is the back end. Both are written using the Qt API. And this this is the part that's currently in progress. I'm mostly working on the UI at this point. So the configuration software is what the user sees. It's a GUI. It's where you customize what key does what, and this is responsible for saving a config file that the service program periodically reads. And for the service, it runs in the background, and it's what listens for the events. And it uses, like I said, the operating system API to take those events and convert them to keystrokes. So how the service software works in a little detail is that it looks for the device on startup and attempts to make connection. And when it connects, it will look for and hook to the UART service on the BLE. So BLE uses something called GAT, which is, it's kind of like a method. It's how it handles sending and receiving data. So a device can have different profiles. So for example, the Bluefruit has a built-in UART profile that you can hook to, and it's not like a traditional UART service. It's just something that acts like it. So you have something called a characteristic for reading data. So that's RX, and sending data, which is TX. And how it sends the data is that the Bluetooth device will send a string. And because it uses the keyboard base, it will kind of send something that's like an HID report, if anybody knows what that is. And it'll send a stop character to tell that the report has been fully sent and do something with it. So all the data is added to a buffer on the service program. And when it sees that stop character, it'll use what's called a QT signal. That's how QT handles asynchronous events. It will tell that to start the message handler and then clear the buffer for more data to be received. And this is just example output. I have it as a console program now, just for easy debugging. So like when it runs, it'll look for a BLE device, and when it finds one, it'll do that. And if it's the device we are actually looking for, it will say that it found the targeted device, and it will attempt to connect to it and find the UART service to hook into. And once it does that, it'll start listening for messages. So you can see that when it receives a message, when I press something on it, it'll send like something that's like an HID report. So it's raw hexadecimal data. So I only need to go through it 1 byte at a time. It doesn't show the stop character because it stops at the stop character. And it'll just keep doing that indefinitely. I think if I have time, I can show a demo, but I think I'm running out of time. So this is just a quick UI of what the software will look like. It's kind of ugly right now, but you can like press a button, it'll open a different state to tell you what you want this button to do. So you can set the modifiers and then enter the keystroke and confirm. It'll go back to the thing, and it'll save the config file. So the result is the service program does successfully connect with the device. It receives data with little to no data loss. So the it's kind of robust, and it successfully translates what the input to keystrokes using the Windows API. And for the software, I do have the basic UI planned out. I have all the data structures kind of planned out as well, but the implementation is still in progress. So what's next? I could maybe do one more design iteration if I have time. I still have to finish the software implementation and just fix out any odd quirks and bugs, but this device is essentially finished. Here's just a schedule I got, and a budget. I only allocated $250. Getting near to that budget allocation, but I don't think I'll need to do any more work on this budget wise. And that's it. Any questions?
Thank you, Luke.
I'd love to do a demo, but I don't think I have time.
No, I'm sorry. We are at the limit. We have another presenter.
Well, this is the device, like physical, and yeah, that's it.